Recently, I modeled the Runge Kutta second order method for solving the differential equations. First of all, let's get help. The function is RK2, the second order Runge Kutta method, and I just say plus F1. So as you can see, the RK second order, it's a second order Runge Kutta method for solving the ordinary differential equations. And here's just this syntax that RK2, here is we're gonna put our function. If we take all other things except dy or dx on the other side, that will be our function, which includes both x and y variables. So we're gonna put this x and y function over there. X naught, the value of our initial point at x-axis. Then if we put the x-axis, if we put the value of x in the function, what is the value of my y1 at x is equal to 0 or x naught? Initially, we're gonna put the value of x and then the number of iterations that we want to perform. But for the instance, here's our differential equation. RK2 is equal to d into I would say not differential equation but our function dy over dx on the one side, and my function which is contained both x and y variable on the right hand on the right side of the equation. 3 into exp negative x minus 0.4 into y, and here's the value of x naught, value of y at x naught, which is 5. X is equal to 3 and 2 is the number of iteration that I want to perform. So it just is all is our solution. You can see the k1, the k2, and my first. So let's just see the code in action. So okay, so my step is just 1.5, which is just derived from this given parameters. My first iteration, my k1 is 1 and my k2 is negative 1.9306, and the value of y at 0 is just, you can say the y naught is equal to 5, and here's the first iteration, which is y1. Now what's going to happen if we go to the second iteration? My k will be turned to negative 1.0514, my k2 will be negative 0.9406, and then my y value will be 2.808. So as you can see, y0, y1 and y2, and we are just getting close and close to our real answer. If I want to just put 5 iterations, so what's going to happen? So here I have just change the iteration from 2 to 5, so h is equal to 0.6, my step size for iteration k1 is 1, k2 is negative 0.5, and here is my y1, 5 point something. After second iteration I got a 4.6, which is y2. After the third iteration, it's also telling me the values of k1 and k2 and also the values of y. 1 2 3 4, y3 is equal to 4, and y just you can see 5 is equal to 0 1 2 3 4. Just of 4 iterations and of 5 iterations we are approximately very close to our answer, which is 2.7814. So if you like it, please post the comments. Let me show its code. The code is so small that I was also amazed by this. Just here's your code. The code will be available soon in the form of M file, and just x is equal to x divided by my iterations. X1 is equal to this one, x2, and I've just inline the function, and then I will start the loop up to the number of iterations that we want to go. After printf, you want to just put the number of iterations and which is inside the loop. So every time the loop will run, we'll get a new iteration k1, k2, y, and just after that the increment in my xi plus 1. So that small code is behind the Runge Kutta second order solving the differential equation. For here I want to just tell that the second order doesn't mean we are solving the second order differential equations. It means that we are taking the first two terms of our Taylor series. Thank you, take care, bye.